Once again, welcome back. This is a continuation of our discussion of word sense disambiguation in the third unit of the NLP. And in the previous lectures, we have seen what is word sense disambiguation and what are the resources that are used for word sense disambiguation. And we have seen about WordNet and how it is used in word sense disambiguation, how it was developed, and these things we have discussed. So, going further, we have also seen the systems used for word sense disambiguation. There, we talked about rule based or knowledge based systems, and we talked about LESC algorithm and how that LESC algorithm is used for resolving the ambiguity of the word sense we have discussed. Now let us see the second type of the systems used for word sense disambiguation. Those are supervised word sense disambiguation. So you know the supervised method of machine learning where we use the labeled data. We have the data X and Y. Y is the label. So we have the labels for the data. And when it comes to the NLP and word sense disambiguation, uh, when we talk about labeled data, that is the availability of manually annotated data, hand annotated data. For every ambiguous word, human experts will provide the word sense. For example, bank. So if it is used in this context, it is financial bank. If it is this sentence, it is river bank. So this type of manual explanation should be available for supervised word sense disambiguation. So supervised word sense disambiguation is a machine learning process, but the only problem is it requires human annotated data. That is which is not available as ubiquitously as possible. Then obviously the supervised methods are high accuracy methods compared to the unsupervised methods. And what we need is we need to determine the sense inventory word and its possible meaning. Those have to be determined at the beginning of that process itself. So when we talk about the process of word sense disambiguation in supervised method, we use a classifier and we train that classifier using various features extracted from the words from manually disambiguated corpus. We select features and those features are used for training, and this model will come up with a hypothesis, and the test data, unseen test data is given to disambiguate the words. And while we select the features, we can also select based on the rules and knowledge. We have to understand when we talk about the features, we have to understand the syntactical relations of that will play in word sense disambiguation. For example, you have a sentence, he charged the battery. Here, charged is an ambiguous because if there is sentence he charged into the room, that means he entered into that room forcefully. So the charged here in the first sentence, charged in the second sentence, in the second sentence, they have different word senses. But here we see that charged the battery. That means here it is related to battery is a direct object, so we can distinguish. So these are the features that will be used in uh, supervised machine learning methods for word sense disambiguation. So syntactic relations are those features, and we have other features also, topic features. So the features that are used, voice of the sentence, whether it is a passive voice, semi-passive, or active voice, there is also feature. Then the presence of a subject or object is a binary feature, whether subject is present, whether object is present or not. If large training data is available, semantic rules can be used instead of subject and object. Then sentential complement indicates if the word has a sentential complement. For example, he believes that project will succeed. Believe is the predicate, the verb, and the sentential complement is what he is believing. He is believing that the project will succeed. This is known as sentential complement. So whether this is present or not is also a feature. Then propositional phrase adjunct, that is another feature that we'll be using for supervised word sense disambiguation. This indicates whether the target word is linked to propositional phrase. For example, she went to the bank. Went to the bank. That clarifies that to the bank. That clarifies that bank is a financial bank rather than a river bank. Suppose she went along the bank, that then along the bank will indicate that it is a river bank. So named entity, which are proper nouns and specific noun, and WordNet, which is the resource, which has synsets and of hypernyms, and those things can also be used as feature. Path feature, in dependency parsing, we identify a head word and other words will be combined to that, linked to that word with feature, with a path. So that path, how head word is linked with other words, that is known as a path, and even that path is used as a feature. And not only that, we can combine a verb phrase from its children and we use that as a frame. So these are the features used for word sense disambiguation in supervised method. Remember these features. Then we have also the algorithm for the syntactic feature selection. How do we select a feature? So if it is a given word, whether it is noun or verb or adjective, then determine its POS, parts of speech, and determine other properties and select it as a syntactic feature. And one more thing we have to discuss is, here we use two types of word sense disambiguation supervised classifiers. One is SVM, support vector machine. Another is maximum entropy classifier. In this algorithm, we'll be selecting the features of different words. We'll be uh, extracting the parts of speech, the voice, and other aspects of the syntactic feature. So we have different methods for feature selection, as we have seen in our machine learning subject. There are filter methods, which will be using statistical measures like chi-square, mutual information, or information gain to rank the features. If you remember in decision tree, we calculated information gain to decide which feature to be kept at the root. Then we have wrapper methods and we have embedded methods, which include L1 regulation, logistic regulation, those methods. Then we can see the classification paradigm in word sense disambiguation. Classification paradigm, it refers to the process of training models to assign a sense label. So the steps in classification paradigm are the training. So a model is trained with annotated data where the senses are manually labeled. Then we extract features from the text. Just now we have seen features which are extracted: voice, presence of the subject, sentential complement, propositional phrase, adjunct, named entity, word net, path features, subcategorization frame, parts of speech. All these features are extracted. Then among the extracted features, you can select the feature by using these methods to get effective features. Then we'll be selecting the model based on the performance, maybe SVM or maximum entropy or naive Bayes decision tree. And once the model is selected, we'll be testing the model for with given uh, test data. Well, previously we have trained this with the known data. Then we'll evaluate the performance metrics such as precision, recall, F1 score, accuracy, sensitivity, these things to assess the model. This is known as paradigm. This paradigm is central for supervised learning approaches in word sense disambiguation. And if our model is correct, we'll get high accuracy. So the classifiers that are used in word sense disambiguation are: one is SVM, support vector machine, which is a binary classifier, though we can use it for regression and multi-class, but basically we know that SVM is a binary classifier. We want to find a hyperplane that separates the data into distinct classes, and this is also called a maximal margin classifier because we want the optimization problem is that we want to maximize the margin between the hyperplane and support vector. Support vector means, if you remember, the closest data points of the class. So even SVM, when we deal with nonlinear data, we'll be using kernels, polynomial kernel, RBF kernel. Then you have other kernels also. Another classifier that will be used in word sense disambiguation is maximum entropy classifier, which is a probabilistic model that predicts outcomes based on the principle of maximum entropy. So the principle here is, given known facts, the model should be unbiased and should make predictions with the highest possible entropy consistent with those facts. So mathematically, we can evaluate the label y given the feature x from this equation 1 by the normalization factor z of x and exponential sigma lambda I fi xi, where fi xi y are feature functions and lambda I is the parameter of the model. Suppose you have to disambiguate word bank, then maximum entropy models will consider features like surrounding words, POS tags, and collocations, local collocations, how these words are used to predict whether it refers to financial institution or a river bank.